Hello students and families, welcome to another video lesson with Mr. Panza. Today's focus question is all about factors. Specifically, how do we find all of the factors of a number? The way I've been teaching the students here at school is using what we call factor rainbows. Factor rainbows are a very colorful way to get to the end of the pot of gold, or the pot o' gold, which is our product number, our product pot of gold. And the way that we get to our product pot of gold number is by following these 4 steps to getting the answer correct every single time. In this video, I will take you through these 4 steps, and then we'll do an example or two together. Let's take a look at the steps. Step 1 is writing your product pot of gold number all the way on the right-hand side. The reason I put it on the right-hand side is because we typically read math problems from left to right, and our pot of gold is going to be all the way here on the right-hand side. So in our example here, we're going to say that we're looking for all of the factors of 10. If I'm following step 1, I simply take the number 10 and I put it all the way on the right-hand side with an equal sign. Step 2 is to start your rainbow with 1 and that number. That number I'm talking about is, again, the product number, the pot of gold number. So I need to start my rainbow by writing the number 1 and 10, because that simply follows step 2. Starting the rainbow means I am making a looping rainbow from the 1 to the 10 that reminds me that my factor 1 times my factor 10, as with any number times 1, is going to get you that number, which is my answer I'm looking for at this point, 10. I need to then move on to step number 3, testing for divisibility. You can use a calculator to test for divisibility, but you have to know which numbers that you should be trying for. I told the students to just write those numbers over on the side or underneath the equation to test a couple of numbers until they've reached step 4 to make sure that they've tested for all sorts of numbers to make sure they're not leaving out any factors. So let's test for divisibility using some of these numbers right now. First, turn on your calculator, and to test for divisibility using a calculator, you need to divide. It says it right there. Divisibility is simple division in your calculator. So I take my largest number, because in division, we're taking a large number and grouping it into smaller numbers, and I plug that large number into my calculator. I'm first going to test for the divisibility of 2. So I divide this number by 2. And if I get an exact whole number, which is what I have here in 5, then I know that 2 is definitely a factor of 5. Because 2 times 5 would get me my pot o' gold number. So I've tested for 2 and I'm good to go. I can also cross out 5 because it's already a factor. But that doesn't mean I stop testing other numbers for divisibility. I should test 3 and 4 at the very least. So I clear my calculator, and I'm set to test for the divisibility of 3. Again, I type in 10 because that's my product pot of gold number, which I am separating or dividing into smaller groups. I'm going to press the division key and divide by 3, which is 3 3/10 repeating. I could also test and see what exactly the remainder is when I divide by 3. It's actually 3 with a remainder of 1. But because when I divide I do not get an exact whole number, that means 3, is not a factor of 10. I can still test 4. Let me clear. And again, I'm still on step number 3, test the divisibility of 4. Take 10, divide it by 4, and I get a fraction again, a decimal. 2 5/10. If I put in my integer divide and I divide by 4, I recognize that my answer is not an exact whole number, which means that 4 is also not a factor of 10. Now I know I can stop, and that's because I'm at step 4. The biggest question is always, when do I stop testing for divisibility? The way I know when to stop is once I've hit the commutative property. Well, I've hit the number 5. But I don't have to put 5 back into my rainbow because I already have stated that 2 and 5 are factors. The commutative property also tells me that 5 times 2 would get you the same exact answer of 10. So I'm done. I follow these 4 quick steps, and I've reached all of my factors of 10, which are 1, 2, 5, and 10. Let's do one more example. If I'm looking at my steps again, I need to write my product number right where my pot of gold goes. Then I start my rainbow with 1 and that product pot of gold number. I test other numbers for divisibility, and then I stop once the commutative property is visible. So let me just take a number out of my product pot of gold. We'll use number 18 for our example. So step 1 is already done. I've placed 18 at the very end, which is my product number. Step 2, start my rainbow with 1 and that product number. So I place the 1 on this line and 18 over here, and then connect it by starting my rainbow. It starts over and loops beautifully here to my pot of gold, which certainly matches because 1 times 18, just like any number times 1, is going to get you that number, 18. But this is not a prime number because it's even, so I need to test for divisibility. That's step 3. I can test numbers like 2, and 3, and 4, and 5. Many students actually like to test all the way up to 9. So let's clear our calculators and start testing the divisibility of 18. I need to type in the large number first, then divide it by 2 to test for the divisibility of 2. And because I have an exact whole number of 9, that means that 2 and 9 are the factors. I place 2 on this. I continue my rainbow by connecting it to the 9 over here. So let's test for 3. Is 3 a factor of 18? 18 divided by 3 gets me 6. So 3 is also a factor because 6 times 3 will get me 18. There's my third rainbow. So 3 is done. Let's test for 4. 18 divided by 4 equals 4.5. That means it's a decimal or remainder. That means 5 does not work. 4 does not work. 18 divided by 5, well, that one also doesn't work because I have another decimal. So 5 does not work. And I've hit step 4. I know that I can stop because the commutative property tells me that 6 is already visible in 3 times 6. I do not have to rewrite 6 times 3. The commutative property tells me that I am done. So when I'm answering this main question, how do we find all the factors of a number? Just remember to use factor rainbows and these 4 steps, and you'll be all right. I hope this lesson helps you out.